Good day. This is lesson 8B entitled Tangent Plane and Normal Vector to Level Surface and Lagrange Multiplier. Let me first discuss to you tangent plane and normal vector to level surface. Good day. So this is the continuation of lesson 8B and I will be discussing Lagrange multiplier. So it says here at what point or points on the circle x squared plus y squared is equal to 1 does f of xy equals xy have an absolute maximum, and what is the maximum? Okay, let's start in defining the function f and function g. Okay, so the function f given here is f of xy equals xy. And the other function, which has this also known as the constraint, is g of xy equals, we have the equation of the circle given as x squared plus y squared minus 1. So what we will do is to find the gradient f evaluated at xy, then we have beta, then we have gradient g evaluated at xy. So with that, let's find first gradient of f evaluated rather at xy. So let's take the partial derivative of the given function with respect to x and with respect to y to comprise or to make up for our gradient f of xy. So with that, let's get the partial derivative of the given function with respect to x. So we have here xy, so copy the constant y, then get the derivative of x, which is equal to 1. Then we're going to find also the partial derivative of the given function with respect to y. So copy now your constant. So constant here now is x. Then getting the derivative of y is equal to 1. So with that, we can now have gradient f. Gradient f is equal to evaluated at xy is equal to yi plus xj, which comprise our gradient f of xy. Then let's define also gradient g of xy from this given equation. So let's get the partial derivative of the given function with respect to x. So here, constant here is y. So let's get the derivative of x squared, that is 2x. Y squared is 0 because that's constant, and negative 1 is also constant. So the partial derivative of the given function with respect to x is just simply 2x. Then let's get also the partial derivative of the given function g with respect to y. So this time x is considered as constant, so getting the derivative here, this is 0 because x is a constant. Here we have here 2y. Then we have here negative 1, the derivative 0 because this is constant. So with that, we can now have gradient g of xy is equal to, we have it as 2xi plus 2yj. Then let us now use this equation and let's define the value of x and y from here. So with that, we now have gradient f equals beta gradient g. So let us simplify this equation in this manner so that we now have del f or gradient f of xy is yi plus xj equals, we have here beta, then you have 2xi plus 2yj. So let us expand this. We now have yi plus xj is equal to 2 beta xi plus 2 beta yj. So collecting similar terms, let us collect. We now have the I component here and the I component here. So we now have y equals 2 beta x. And expressing beta in terms of xy, so we have y over 2x. So let us have this as equation 1. So likewise, let us collect also the j component. So this is the I component, then the j component. So we have here x is equal to 2 beta y. So expressing beta in terms of xy, we have x over 2y. Let us call this as equation 2. So we're going to equate the two equations. So equation 1 equals equation 2. So with that, the resulting equation, we have here y over 2x is equal to x over 2y. You can cancel 2, and then you can cross multiply. The answer is x squared equals y squared. So solving for x, we now have plus and minus y. So with that, if we're going to substitute this equation, let's call this as equation 3. In the equation that we have here, so we're going to set this to 0. So let us call this as equation 3. So let's set this to 0. Then call this as equation 3. Therefore, we can now, or rather, this is now equation 4, because we have here already equation 3. So with that, substitute equation 3 in 4. So let's make y squared equals x squared. Okay, so let's have that. X squared plus, we have this y squared is also x squared, minus 1 equals 0. So we get 2x squared equals 1. So therefore, x squared equals 1 half. And the value of x will give us plus and minus 1 over square root of 2. So in that case, if x is equal to plus and minus 1 over square root of 2, so we can also now define what is y here. So we can also write this as y equals plus and minus x from this equation. So instead of having x equals plus and minus y, we can also write this as y equals plus and minus x. Suppose now when x equals positive 1 half, or rather 1 over square root of 2, so your y will also be 1 over positive square root of 2. If this is x equals negative 1 over square root of 2, then we can now have also y as negative y over square root of 2. So we can have that. So with that, we can now determine the points on the circle x squared plus y squared equals 1. Does this function have an absolute maximum? So with that, the points here, we're going to pair positive 1 over square root of 2 with positive 1 over square root of 2. That will be our first point. Second point will be, let's have the pair 1 over square root of 2 and negative 1 over square root of 2. Then let's have the third point. We're going to pair positive 1 over square root of 2 with negative 1 over square root of 2. Oh, we have that already. Okay, let's take negative 1 over square root of 2. Then we'll take positive 1 over square root of 2. Then lastly, the fourth pair of point will be negative 1 over square root of 2 and negative 1 over square root of 2. So how do we find that maximum? Okay, so from the function that we have here, f of xy equals xy. So the first point, when we multiply this, the value will be 1/2. Okay? At the given point, p sub 1, so we have the value of the function f of xy will be 1 over 2. When this is at point 2, the value of your f of xy with the corresponding coordinates here. So we can replace this as 1 over square root of 2. 1 over square root of 2. So f would now be, with this given point, p sub 2, 1 over square root of 2 and negative 1 over square root of 2. The answer is negative 1/2. So same with the third point now. We're going to make use of f of 1, negative 1 over square root of 2 and negative 1 square root of 2. This is your third point, or rather positive. The answer is negative 1/2. Then let's have here, with the corresponding coordinates of this P4, the value of f at negative 1 over square root of 2, negative 1 over square root of 2 will be 1/2. So the 2 points that will give us maximum value of 1/2. So this is the final answer. The final answer is 1/2 is the maximum value at the given point P1 and P4. So this is how we solve for this problem.